Oftentimes, this human in the loop is seen as a bottleneck or maybe a slowing point, but it's actually quite important. This human in the loop is really what enables us to ensure that the outputs that we're putting into production are high quality. Hello, my name is Marina. I am an AI engineer here at Visium. My background is actually in biomedical engineering as well as AI. So as I was finishing my studies, I actually started to get more into the world of medical imaging, and that came hand in hand with things like computer vision, medical image analysis in an automatic way with the help of AI. And this is kind of how I fell in love with this world. Here at Visium, I work as part of the product team where we have multiple agentic products, mainly focused on the pharma industry. So when we talk about agentic AI, what we are really referring to is AI systems that are able to make decisions, to plan and execute tasks in an autonomous way in order to reach a goal. So if we compare it to ChatGPT or Gemini, chatbots that most people are familiar with, in those cases, usually we have a user that is asking a question, and the large language model behind this chat will actually generate a response in the form of a text or an image. Well, in Agentic AI, what we are doing is that we are putting the same large language models behind a decision-making pipeline. What this means is that we can give an agent a certain goal that we want to reach. The agent will analyze this task, analyze its environment, meaning what tools does it have access to and what knowledge base does it have access to as well. And then it will go in a loop of planning and executing tasks until it reaches that goal. And this is really what it makes our system agentic. At the moment, it's becoming really popular for automating chatbots that can be helpful in their work life. So, for example, we have agents that are experts at navigating knowledge bases. So I'm sure most of you at your company have a lot of documents that are maybe stored in a drive or any other cloud provider that you may have, and you often find yourself manually searching through it. Well, now this is shifting towards having an agent that you can directly ask a question just in plain language, like you could maybe ask a colleague, and the agent will navigate this large knowledge base and then give you the answer, like if you were already asking the IT team or a different colleague that may be an expert in the specific field that you need help with. Now that we have defined what agentic AI is, it's important to note that in production systems, we rarely find agents working by themselves. What we usually find is that agents need to work in a team, and this is really where orchestration comes in. As an AI engineer, we have to put a focus on defining how agents are supposed to interact, what is the knowledge or the flow of information that we expect between agents, and what is the scope of work of each one of the agents in a team. And it's through the process of defining all of these factors that we are really orchestrating our team, and we are taking our agents from being really good at excelling at executing their tasks on their own to really being able to collaborate with others and therefore tackle larger tasks. So it's like you would work with other colleagues or teammates at your work. In that same way, we are enabling agents to share their different tools, their areas of expertise, and therefore being able to tackle a lot more complex tasks. A really good example is actually our agentic clinical document drafting platform here at Visium. So basically, clinical documents are very complex by nature. In order to draft one of these documents, a team of experts is required, including a medical writer, or compliance expert, maybe statisticians as well. So when we started tackling this problem through agentic AI, we quickly noticed that this challenge was going to require of agentic orchestration. So to give you a little bit more details, how we actually make this possible in our team is by assembling a team of expert agents that are able to collaborate together. Some of these agents are, for example, information extraction agents. These are agents that are really experts at, for example, navigating a CTP or an SAP and extracting those key pieces of information that are going to be needed in order to draft a new document. We also have statistical agents, we call them, and these are agents that have advanced reasoning capabilities. They have access to coding tools and direct connections with databases. What these agents are going to do is that they will plan the statistical analysis that needs to be carried out based on the data. And then they will execute this analysis and ultimately give rise to the tables and the figures that are going to be included in our document. Finally, we also have compliance agents, and these are agents that are experts at understanding regulatory guidelines, and they will be double checking every piece of information that is going into our final document. So as you can see, by allowing these agents to work together through fine orchestration, we really go from separate agents that excel at different tasks to really having a group of agents that are able to give reliable outputs and making our system a lot more robust and production ready. This is a very common question. People are often wondering, well, why don't we just set up one super agent that is kind of able to do it all? And the answer here is complexity, and it can really scale quite fast. So actually, if we think about setting up one of our agents with 30 different tools and 10 different responsibilities, what we are actually doing is that we are increasing the likelihood of tool misuse, irrelevant reasoning, and just really bad output quality. So what is best practices in production is to split all of these tools and all of these responsibilities into specialized agents in a way that each one of the agents only has access to the tools that it needs, and it has clear instructions on how to use them. I'm sure everybody can understand this by comparing it to their work, in which we don't usually have one person that is able to do it all. What we have is different people that are able to collaborate in a team and work together to reach a certain goal. How we usually do this in practice, there's many steps that we need to take. One of them is through prompt engineering. So it's really important that we give each one of our agents robust instructions on how they should behave, what are the tasks that they should accomplish, and what are the tools that they need access to. Along those same lines, we also need to define tools that come with enough instructions for the agents to understand how to use them. And then, of course, you have to enable this agent interaction between one another. And this can be done in many ways. One of the most common ones is by defining actually an orchestrator agent. And this will be the agent that actually has reasoning capabilities or more advanced reasoning capabilities and will know what other agents it has access to and what are the specialized areas for each one of the agents. And therefore, it will be able to give different agents different tasks in order to reach a certain goal. This orchestrator agent also is as well the one that will be assessing the final output and deciding when the final result that they have achieved is actually enough and should be retrieved to the user. Something that I've learned since coming into this world of agentic AI is to solve for reliability before you try to solve for autonomy. So oftentimes when we are facing a challenge of automating a task that can be quite complex, we start setting up the system that can rapidly become really large. We have multiple agents with multiple tools, and in reality, the outputs that we're getting are not reliable. We don't really understand what's going on inside the system that's actually giving us these responses. So I think what is the best approach and what we recommend is to really start small, make sure that we are understanding what is the expected output from each one of the agents, what are the tools that each one of the agents is going to need. And like I said, putting a strong focus on prompt engineering of our agents, and then slowly scaling this up. Along these lines as well, I wanted to bring up the point of human in the loop. So oftentimes this human in the loop is seen as a bottleneck or maybe a slowing point. but it's actually quite important. This human in the loop is really what enables us to ensure that the outputs that we're putting into production are high quality. So here at Visium, across our products, we actually put a strong focus on enabling agents to work side by side with the experts in whatever industry our product is going to.